Hello again, Algebra 2A. Today we are looking at Lesson 21, solving systems of equation using substitution. And that is our goal, is to solve these systems using the substitution method. So far in Lesson 15, we've talked about how to solve a system of equations using the graphing method. Now we are looking at the second method, which is using substitution. Substitution means to replace, and that's exactly what we're going to do when we use this method. We're going to replace a variable for an equivalent expression in the other equation. So we'll practice that here with example 1. In order to use substitution, we have to get one of our equations solved out for a single variable. So you'll do a quick scan of your equations, and you'll look for any variables that are just by themselves. Like here I just have a plain x, or down here I just have a plain y. Those variables would be very easy to solve out. So we're always looking for a variable that has no number in front of it, just a plain letter. And we're going to solve out for that variable. Once you've identified the equation you're going to solve for a single variable, you can start to use algebra to get it solved. So now we have an equivalent equation, y equals 4x plus 18. Now here's where the substitution comes in. Now we have a variable y equal to this expression, 4x plus 18. Now I can use that 4x plus 18 as a substitute for y. So we're going to take this whole expression and we are going to substitute that in for its equivalent variable, y. After that, we'll start writing out the new equation. And what we have done is we've got an equation now that has only one variable, has an x, and that's it. So what I've done now is I've done the replacing. So you'll notice that the y is now gone, and I've replaced the y with the equivalent expression 4x plus 18. From here, we're just going to do our algebra. So we'll start with the distributive property, and when I get back, we'll have our equation solved out for x. So you'll go through and you'll solve your equation for x, and we'll get x is equal to 4. Now we're ready to do our second substitution. Now we know that x is negative 4. We kind of know half of the variables in one of our equations. So we could use this equation, y equals 4x plus 18, and we can do our second substitution, put negative 4 in for x. So when I get back, that's what we'll see next. So we've now taken y equals 4x plus 18. We've replaced the x with negative 4 because we now know x is negative 4. And now we're ready to solve for the y. When we do that, we'll get y is equal to 2. And we always write our final answer as an ordered pair. So our answer is negative 4, 2. We'll now take a look at some special cases that happen when we're solving systems. We looked at this with our graphical solutions in lesson 15. So classifying systems, if we have intersecting lines, that would be an independent solution, and that's a consistent system because it has a solution. Coinciding lines would be called a dependent solution, and that's also a consistent system. Remember, consistent systems mean that they have a solution. And then parallel lines would mean no solution, and that's going to be an inconsistent system. So we're going to look at how substitution looks when we get one of these special cases, and then we'll classify our system. So first thing we'll look for is we'll look to see if we have a variable solved out, and this one's set up for us. We got y equals negative x minus 3, so we'll take negative x minus 3 and substitute that for the y. So that's what you'll see that I've written here is we've got an equation set up. 3 times negative x minus 3 equals negative 3x minus 9. So now we'll start to solve for x. After I did the distributive property, I'm starting to notice something unique happening. I've got negative 3x minus 9 equals negative 3x minus 9. So I'll get my variables collected on the same side, which will mean add 3x. But we'll notice that our variable parts will cancel out. Well, that's going to lead us to this special case. So here I've got negative 9 equals negative 9. If this statement is true when your variables cancel, and that's a true statement, this is going to mean we have an infinite amount of solutions, which means we're dealing with a dependent system. So we'll say that's dependent. That tells people that that is a system with infinite amounts of solution. So when we see our variables cancel out and we get a true equation at the end, we're dealing with something that has infinite amounts of solutions. Doesn't matter what number you put in for x or y, you're always going to have that solution work. I beg your pardon, any xy pair on those lines is going to be a solution. So we have an infinite amounts of solutions. So I've scanned over both equations, and I did notice our second equation is solved out for y. So again, we can take that expression 3x minus 3 and we can substitute that in for y. Now we'll start to work at solving for x. So similar to before, our x's are going to cancel out because we got a negative 3x and a positive 3x, and then we're left with the equation negative 3 equals 2. Well, obviously that is false. We do not have a true statement here at the end. We got negative 3 equals negative 2. That's not true. So this one is going to mean that we have no solution, which is an inconsistent system. So anytime we have our variables cancel out and the resulting equation is not true, this would be an inconsistent system. So there would be our result. As I look at my last two equations, I do not see a single variable alone. So here I'm going to have to take one of these equations and solve it out for either x or y. I'm going to choose to take the second equation. So I'm going to rewrite that equation up to the right of the system. So I'm going to go ahead and solve this one for x. So I'm first going to take my y term, move it to the other side of my equation, which gives me 3x equals 2y plus 8. And then to get x alone, I'll divide everything by 3. So now I've got an x equal to 2/3 y plus 8/3, which I can now take. Since x is equivalent to that, I can take that expression. And in the other equation, remember I used the bottom equation. In the other equation, I can replace x with that quantity. So now we'll take 2/3 y plus 8/3, and we'll take that whole quantity and put that in for the x, since those are equivalent. So what you're seeing now is the x now replaced with my expression 2/3 y plus 8. So now I'll go through using algebra to solve this out. So when I get done with the next step, I'm going to have distributed the 4 out. So I've taken the 4, distributed it out. 4 is like the fraction 4 over 1, so I only take 4, multiply each numerator in the fraction 2/3 and 8/3 to start to multiply those fractions. Next, I'll combine my like terms. I've got a 3y and an 8/3 y. Now I'm going to think of 3y as 9/3 y because then I have a common denominator to add up to make 17/3. So 8 plus 9 is 17. And then I've already taken 5 and written it in thirds because I'm going to have to subtract over this 32/3 next. So that's what I'll do on my next step. And I'll subtract over 32/3, which gives me 17/3 y equals negative 17/3. Divide both sides by 17/3. I'm going to get y is equal to negative 1. Now that I know y is negative 1, I can put that back in for y over here and then solve for x. So I'm going to do that in this next column over to the right. So once we know that y is negative 1, we'll take negative 1 and put it in for y. So x is equal to 2/3 times negative 1 plus 8/3, which in turn is going to make negative 2/3 plus 8/3. Add the 2, negative 2, and the 8 gives us 6/3, which is equal to 2. So then we're left with our solution 2, negative 1. So when x is 2 and y is negative 1, that would be our solution. In lesson 24, we're going to learn about our last method, which is called elimination. And this one would be a good candidate for elimination because none of our variables are alone, which makes it a little harder because you start getting fractions and things. So this last one would be a good candidate for elimination. That's something we'll be practicing when we get to lesson 24. So that does it for our learning target today, solving systems by substitution. Sometimes we'll get the variables to cancel, then we got to look whether or not do we have a dependent, consistent, or do we have an inconsistent system. Thanks for joining, and we'll see you next time.